Ready? So please pay attention, everyone. Just solving more problems relating to substitution with or without trig. The first few questions are not past questions, but those other ones are past questions. So just more techniques. Two ways. This could be arc cos, or you could just remove the sign and make it arc sign. Okay? So well, whichever one, but just stick to the arc sign that we are used to. So again, you need it to look like a square. So if I take that out, I get minus 5 out. Then I have the square root of 1/3 all squared. Please, I will encourage you to do that. Don't just, jump. Okay? Since you are not discontinuity, so don't jump. Okay? Jump. So minus 5, and that will be arc sign of x over a this time around, x over 1/3 plus c. And that is how I've seen a lot of you wrote 3x plus c. Okay, so well done. And this also is similar. Again, if your name is not discontinuity, don't jump. So this is 3 squared plus x squared. Okay, show the examiner you know what you're doing. You're expressing it in the standard integral form. So this is 1/8 times 18 times 1/3. Yes. Then it arctan this time around of x over 3 and plus c, of course, before you write the last result, which will be 6 arctan of x over 3 plus c. Okay? And for this too, I intentionally put this first so you can see a pattern. So it means the technique here is that express using the completing the square method. So we're going to express these two functions. So I've seen a lot of you doing your completing the square method within the integral. It doesn't look nice. So take it out, express it, whatever you get, put it back in. So we're going to put that here. Minus x squared plus 10x minus 24. This minus can't just leave the square root sign. We're dealing with real value function, not complex valued function. So we can't do what is not defined in that sense. So it's going to be minus. Then I'm going to have, you're welcome to just take care of the first two and leave this 24 out of all the problem. Then later you combine whatever constants you produce. So this is going to be minus. Then I'm going to have x squared minus 10x. To make this square, you are going to have to add minus 5 squared. But because it's an expression, we can't add to any side because there's no both side here. You add it and you remove it immediately. So we are going to be adding minus 5 squared and removing minus 5 squared immediately. The minus 24 is waiting outside. Okay? So that the first 3 becomes x minus 5 all squared. Then you have your minus 25. This minus is here. This minus 5 squared is plus 25. So again, you have that. Minus 24. Okay, so that if we open the bracket, it becomes minus x minus 5 squared plus 25 minus 24. So that becomes plus 1, which can be 1 minus x minus 5 squared. So if this comes under the square root, it looks like this form, where a is equal to 1. So that's the point here. So we don't have enough space. I'm going to have to erase this, and okay, maybe I put it here, if you guys don't mind. So after this, so, okay, can we see this? The original question, integral, the square root, minus x squared, plus 10x, minus 24, dx can be here or here, doesn't matter, can now be written as integral dx over the square root of 1 minus x minus 5 squared. And that is just arc sign, yes, with a as 1. So that is simply arc sign of x minus 5 divided by 1, which is just x minus 5 plus c. Okay? Calista? Is that a problem?
Oh, the minus 2.
Minus 2. Oh, okay, sorry. So there's a minus 2 here. So which we must have taken out here. Then this is minus 2. Is it okay now? Yes? So similarly, express this first. So 4x squared plus 12x plus 10. So 4 brackets x squared plus 3x. Then 10 is waiting outside. You don't have to consider that because it's just having more fraction and fraction. So this is going to be 4x squared. What do you add to x squared plus 3 to make it a perfect square? 3 over 2. So you get 3x plus 3 over 2 minus 3 over 2 squared. Then you still have your plus 10 waiting outside this bracket. Understand? So that you get 4x plus 3 over 2. This is minus 9 over 4. Then you still have your plus 10. So if you open the bracket, you have 4 brackets x plus 3 over 2 squared minus 9 plus 10. Is it? Is it? Which is 1. Okay. So maybe something is wrong. So this will be 4x plus 3 over 2 all squared plus 1. Is it? So 2 ways to do this. Not necessarily 2 ways. So the original problem is solve the original problem integral dx divided by 4x squared plus 12x plus 10. Lillian, did you guys get this? Did you get this? Okay, so you should check your calculation. So that will be the integral of 4x plus 3 over 2 all squared plus 1 dx. So again, you can't just assume this is your x. This is not your x. Your x is that function of x that is all squared. Okay? Your x is that function of x that is all squared, no constant before it. So this has to be gotten rid of. To do that, this has to be 1 over 4. Understand? So this must have been 1 over 4 integral x plus 3 over 2 squared plus 1 over 4 dx. Yes? And that will have to be 1 over 2 squared because this is also a square. Okay? So that will be 1 over 4 integral x plus 3 over 2 all squared plus 1 over 2 squared, and you have dx. So compared to this, 1 over 4 is a constant first. Then your a, Karen, 1 over a will become 2. Yeah, agree? Can I just write 2? Because that's 1 over half, right? Then you have arctan x over a. X over a will be x plus 3 over 2 divided by a is divided by half, which is times 2. Such that this is 1 over 2. Arctan, of course there's a plus c. So this will be 2x plus 3. Then times 2. So the 2 we cancel. So you'll be left with 2x plus 3 only plus c. Because there will be over 2 here and there's times 2 also, so to cancel. So I skipped that because there's no space. Okay? So if you didn't get this, please check your calculation. Okay. I would encourage you to please learn that as well. So it's similar to this. It's similar to this. So this is an IB pass paper. This is an IB pass paper. You've been given a clue already. U is this. It doesn't mean you need some du dx, blah, blah, blah. Okay? Of course we do, because if you transform it, then, you know, you are going to have to change your dx to du. Okay? In any case, du dx is equal to just exponential x. So which implies that our dx is equal to du divided by exponential x. So you keep that. Similarly, this function, if u is this, you need to try to express this function in terms of this. So this function, exponential 2x plus 6 exponential x plus 13, everything has to be outside the integral. So you need to try to complete the square. So this is like p squared plus 6p, right? So what do you add to 6p? 3 squared, isn't it? Talk to me, do you understand? So this is going to be equal to, exponential 2x, 6 exponential x plus 3 squared minus 3 squared, then you have your plus 13. So that this can be a square. Alright? And that's why you were given plus 3, because it's going to be exponential x plus 3 all squared, then you have minus 9 plus 13. Okay? Which will be exponential x plus 3 all squared, then you have plus 4. And you've been given this to be u. So this is going to be u squared plus 2 squared clearly at the denominator. And because in the transformation, when everything becomes u squared plus 2 squared, this remains dx, and there's a function of x here, which needs to be gotten rid of. That is the reason for this one. So everything can now be put together. So the original question, integral of exponential x divided by exponential 2x plus 6 exponential x plus 13 dx becomes integral, yes, the denominator has been transformed to u squared plus 2 squared. You can make it 4 here and put it as this here, it doesn't matter. Okay, and this remains the exponential x, while this becomes du divided by exponential x. Understand? Such that this becomes what? Together now. Say that again. 1 over. Actually, I would rather leave this as 4 here. Leave this as 4 here. Then I can write it as 2 squared. Okay? And what is that? 1 over 2 arctan. No. U over 2. There's no u squared, please. U over 2. Okay, then you write the final result. 1 over 2 arctan. What is our u? Exponential x plus 3, everything over 2 plus c. And that's it. 7 points in the exam. Isn't that a cheap Christmas present, 7 points? So for this one, similarly, there is something here I want you to observe. You are given that substitution. Of course, whenever you are given a substitution, you need to differentiate, isn't it? So if you have x cubed is equal to 3 sec x, what comes to your mind? No speaking from you, miss, because I'm guessing you have an idea. What comes to your mind first? We need to do something like this, isn't it? Right? So tell me what comes to your mind when you see it. What kind of differentiation comes to your mind? Come on. Don't whisper, talk to us. Come on, somebody just try. Say that again. N squared, not quite. What? Is it what? Cots. The derivative of what? The derivative of a sec, right? I'm not talking about that, but look at this function. There is something, it's not like this.
Put the x into the square root.
Say that again?
Put the x into the square root.
Put the x into the square root?
Yeah.
I'm talking about differentiating this, you're talking about putting x into some square root. We're not even there yet. When you have a substitution, you're supposed to differentiate, because there will be transformation of variable, isn't it? But to differentiate this, it doesn't look like the normal direct differentiation. So what is the first thing that comes to your mind? not saying what I'm saying here. Clarissa, you look like your eye is saying something, but you don't want to speak. Speak louder, please. What did she say? That's it. I knew it. Yeah, could read your eyes. Implicit differentiation. Remember that differentiation where you have x squared plus y squared is equal to 2xy. Y is not given directly in terms of x. So we say y is not given explicitly in terms of x. In this case, your variable is given explicitly in terms of x. Understand? Even here, it's given explicitly in terms of x. Here, explicitly in terms of x. But here it's not. So you use your implicit differentiation. Okay? So if you want to get dx d theta, or if you want to get d theta dx, it's now up to you. If I want to do dx d theta, it means my x is like my y. So each time I differentiate x, I must put dx d theta. Am I making sense? Remember, compare it to dy dx. Anytime you differentiate something involving y, you apply dy dx, and I've told us why. So if I'm focusing on dx d theta, of course I can change it later. If I'm focusing on that, it means this will be 3x squared dx d theta. Right? What's the derivative of sec? Sec. Check your derivative formula. That should be sec tan. Sec theta tan theta. So this will be 3 sec theta tan theta. Okay? Remember, this is dx. So it means we need to make the theta, the dx the subject, so we can transform. So in that case, my dx will be equal to 3, is it? No. Yes, 3 sec, talk to me please. 3 sec theta tan theta d theta divided by 3x squared. So which should be sec theta tan theta d theta divided by x squared. Okay? Then maybe we need something for x squared later, we will see. Alternatively, you can make this your dependent variable, y. And this one remains what x will do. So if I have x cubed is equal to 3 sec theta, if I assume that my theta is my dependent variable y, understand? Then this just remains 3x squared. So this will be 3 sec theta tan theta followed by what? D, say that theta dx. So exactly the same thing I did here. But here I assume my x is that dependent variable y. And anytime you differentiate the function involving that dependent variable, you apply dy dx. Right? So the same thing here. So you can do the same. So if I need to make my dx, so this comes here, right? And this becomes the new denominator, which is exactly this. So this still gives you this. Your choice. There should be no ambiguity. Regardless of which approach you use, you must be able to get this. We don't know what happens to this, but let's see when we begin to put things in. And the fact that it's given us an arc course, you can see why, because of that, right? Okay? And the arc course should be, there's a minus that should be introduced somewhere. We will see, we don't know. So let's see how we can transform this. Let's see how this is transformed. So the original problem, integral dx divided by x square root of, this is where your putting into the square root comes in. I thought we were not there yet. So if x cubed is this, then x to the power 6 will be what? This square. Right? So it's going to be 3 sec theta squared minus 9. Right? No, I should write the original question first. I'm looking at the space also. We don't need this, so we can actually make use of everything. Do I write here? Let's just begin here. Okay. All right. So the original problem, integral dx divided by x roots. Miss V, can we see this clearly?
Yep.
Okay, good. So that will be integral dx is what? What is dx? Everyone? Sec theta
tan theta
tan theta
d theta
d theta
over x squared
divided by x squared, okay, divided by x squared. So I think I should write it this way. For obvious reason, okay, because now this is a fraction, so I'm trying to separate them. So we can see clearly to avoid any confusion. So let's put this first. Our x, there's nothing for x for now. Square roots, sec, right? Talk to me please. 3 sec theta squared. Okay? 3 sec theta squared minus 9, 1. Instead of the x, then we have what? Sec theta, tan theta, d theta over x squared. Okay? So this is the integral. Yes? What next? Talk to me please. You should see something already. Let's take it one step at a time. Yes? We make 9 to 3 squared. No, not immediately. We can leave this as x, and we can open this bracket. What would that be? 9.
x squared
So you don't need to make 9 3 squared because you can factorize now, and 9 can escape the square root. Okay? And this will still be 1. These guys remain what they are. Even that should be, this should be cubed, so that this remains sec theta, tan theta, d theta. Can we see that? What do you suggest next? Okay, what do you mean by that? 9 will be factorized. Okay, so what do I write? I don't think so. Say that again. Speak louder, please. Sec theta, because x cubed is 3 sec theta. Remember, the goal is to change everything to theta form. The function in terms of theta. So every opportunity you try to kick out x, and obviously this is the only thing affecting our workings, and there's a reason. So this and this combine to give us a cube, so we're good. Now we don't have any x business anymore. All right, we've moved to theta business now. Then things are looking promising. Unlike before, it's like, oh my God, the future is, unknown. But now we can see clearly. All right, just like the vaccine. Oh my God, there's no vaccine. Oh, there's vaccine now. Hallelujah. Even though we don't have it yet, but at least everyone is thinking, oh yeah, I'm gonna get it someday in 2021. I can travel again. But for now, we are all stuck in Macau. Good luck with that. Don't worry, we'll be fine. So we have, yes. What do I do under this? 9 bracket sec squared theta minus 1. I don't know how we're gonna get out of that one. You're gonna have to help me. I've got no clue. I know 3 will come out, yes. I know sec will cancel sec, yes. So how do we get out of this mess?
Tan squared theta.
What?
Tan squared theta.
You sure it's tan? Are you sure it's tan?
Yes.
Yes. Remember, if you don't remember, sine squared plus cos squared is equal to 1, right? How do you get sec? When you divide by cos, isn't it? So if you divide by cos squared, cos squared, cos squared, you don't need to memorize. This is tan squared, this is 1, this is sec squared. So when you take this away, sec squared minus 1 is tan squared. No need to memorize. So, what do we have next? Integral, yes? I think we can easily just cancel this so we don't write too many things. Okay, so at the top we have tan, at the bottom we have 3 square root of sec squared theta minus 1, and here we have tan theta d theta. Yes? So everything becomes the integral square root of 9. You see, I'm taking it step by step. So I can have 1 over 9, correct? And inside the integral, what do I have now? Tan theta over tan theta, which is 1. Okay, d theta. So 1 over 9 integral d theta, isn't it? And what is integral d theta? Just theta plus c, yes? So this is going to be 1 over 9 theta plus c. It's looking promising because we have our 1 over 9. So what is theta? Oh, we don't have anything for theta yet. So try to form something for theta. Because clearly, so here, before we move to this part, also from x cubed is equal to 3 sec theta. From here, it means that sec theta is equal to what? X cubed over 3. And if sec theta is x cubed over 3, because the result is not meant to be in terms of sec theta. Here we could say theta is equal to arc sec, right? Inverse sec, okay, of this. But that's not what they want us to get. If this was not given, then that would be an acceptable result. But what you must obtain has been given, so you change it to that format. So it's in this case, remember this is 1 over cos to be x cubed over 3, which means cos itself will flip 3 over x cubed, and consequently theta is equal to arc cos of 3 over x cubed. Then we put that here, and that becomes 1 over 9 arc cos of 3 over x cubed plus c. Very sweet question, isn't it? Second point. I think we all agree that 7 points is better than this 7 points. But who knows? So the idea is learn different manipulations, different things. There are 2 of these that I put on the worksheet from different years, I believe. I put them together in the worksheet. So with this, I need you to try the other one on your own later, not immediately, okay? So let's see what we need to pick here. Maybe I'll just take I'll just take pictures. We go to integration by parts because of our time. Remember, you have to leave in about less than 20 minutes, actually. Okay, I'll take a picture. We can stop that and record for the next topic.